wanted to I wanted to put a plug in for Friday. Carl has offered to do a behind the scenes tour at the new Smithsonian Greenhouse. So if you haven't signed up and you would like to join with that, please look at Kathy's email that went out with a link where you can reach out to Carl to let him know you're coming. Um, and I recently learned something very exciting about this society, that there used to be skits by members.
No.
Yeah. So, as
Like,
president,
you know,
right. So don't worry, Devin. But as somebody who has a lot of responsibility in December as the president to do some kind of presentation, just check your emails because I might be calling out to you all for to reinstitute this wonderful tradition of skits. Anyway, we are ready to begin. Thank you, everybody. We have a great turnout online and in person here. So thank you for showing up. And I'm going to turn it over to Carl.
Just a quick introduction. Good evening, everyone. Tonight we are fortunate to have Devin Floyd, founder and director of the Piedmont Discovery Center, an organization that provides action-oriented opportunities for the public to learn about the natural wonders in their yards, parks, forests, fields, and streams. Take it away, Devin, and thank you.
Oh, thank you for that introduction. Um, Devin Floyd here. I am really excited to be here. I've been coming here since I was 5, and I used to live not far away in College Park. And had our kids, I would bring them here. Started when they were 2 weeks old in the sling. This is where we would come, to this museum. So I love this place. And yeah, so it's nice to step into the giant curiosity cabinet and with something curious. And I just want to let you know that I am an archaeologist. So I'm not a botanist. Most of our conversation went over my head on grasses, lichens, same thing. Not like so
You're the genus name.
Xanthoparmelia. Yes, exactly. So I found myself needing to stop doing archaeology because it hurts, and so I'm a pretty decent educator, and I have an obsession with natural history and trying to find the connections between things that are seemingly disparate. And that led to an idea for starting a thing called Blue Ridge Discovery Center, which is down near White Top Mountain, Mount Rogers, that area. And then it left that adventure and started Piedmont Discovery Center as a similar thing in the Piedmont ecoregion of the Eastern United States. Natural history, action-oriented, research-oriented now. So I just gradually fell into the position of there being a big problem in the conservation community and no one addressing it. I didn't think there was anyone addressing it. There were thousands of people addressing it or trying to. Um, and so it forced me to learn about plants. And in archaeology, one of the things you just kind of have to be good at is understanding correlations between past land use, geologies, and plant patterns. You have to be able to read a landscape, see where the house is without a house being there. And that translates directly to natural plant community recognition, classification, geofloristics, associations between plants and their strict fidelity for certain geologies and things like that. It translates quite well. So I took to that well. So I found myself in this situation of needing to stop archaeology. I was working at Monticello, and I took the leap and decided to start this organization, which was, kind of a triad. We wanted to do some restorations at schoolyards and in yards, and we wanted to model those native plant community restorations after documented wild reference sites. And then we had to produce the plants. So then there needed to be this local eco-type production, and it was tiny. And that kind of stuck and took off. And eventually we got hired to do some biological assessments in the wake of pipelines going in Appalachia. People wanted us to find rare plants or a weird archaeological situation. That was when we first started stumbling upon this weird plant community that wasn't a forest. It wasn't an abandoned agricultural field. It wasn't an old pasture. It was a grassland of extraordinary diversity. And we had no idea what this was and why it was in the Eastern temperate landscape. And that question was kind of, ever present as soon as we stumbled upon that. And that has been a driving factor in the research department ever since. What the heck are these things? What are these grasslands? This is a picture of one on the screen.
Where the buffalo used to.
Yeah, I'm glad you've got your bison back out on out there, even though they're a little bit big. Yeah, so the picture on the screen, this is my screensaver. This is at South Run Park, Spring Park. This is a remarkable remnant landscape, an old Savanna leftover. It was just sitting right there in front of everyone. Unplowed soils. And what that means is you've got 200 to 300,000, hundreds of thousands of years of geologic soil, eluviation, stability. It's a flat, hard pan landscape. There's no erosion happening. It's imploding chemically, physically, hard pan. And so the plant diversity is sick. So that's the problem. That's it. So what I'm going to do today is I do bring archaeology to this, and that makes these presentations weird. It's sort of I'm pushing against the archaeological research with the ideas that we hear today. I'm really a thorn in the side for a lot of ecologists and botanists. I'm kind of in the middle because in the middle there's this thing that's being missed, and I'm hoping through education, outreach, ultimately research and letting the plant speak through data that things can begin to change, and they have already. We'll talk about that. So my presentation today is not going to be a traditional PowerPoint because I don't have one. We're right in the middle of research. I don't have time for it to make a PowerPoint for a presentation. What I've got is a series of notes and a couple of PowerPoint slides left over from other presentations. And the reason I'm taking that approach is because I want there to be questions. I want some feedback here. I'm looking for skeptics, light bulb moments, in the concepts that are addressed in here. Okay. So, with that, I'll just go ahead and start with this. Let's go ahead and show this screen.
Yeah. Okay.
All right. So, this is Dr. Jordan Cassia over here on your left. That's master's student Ezra Stengel with the camera. That's PhD botanist, ecologist Leighton Reed in the center. And everybody's just dumbfounded because we stepped into this weird place. It's a time capsule, and it just kind of goes against something we had long assumed. So what happened with this whole adventure? It really started in 2014 when I stopped being an archaeologist. I was looking for a house, went down this long driveway in Albemarle County. It cut through a power line right of way, a high transistor line. And I drove through this weedy patch that was just floristically really complex, really gorgeous. Anybody recognize any plants in there? It's a hard time of year, November, but you're a botany group. So Euphemia, Eupatorium, Pycnanthemum, just some hard to read grasses in there. Sorghastrum probably. Yeah. So, what is this? How is this possible? Because everything I'm used to seeing is, tall fescue, common ragweed, common milkweed, purple top tridens, these old broomsedge, these old abandoned plowed regions of the Piedmont, right? Where everything looks kind of the same. Lots of fescue and bluegrass. but not this. And so it just really, really piqued my interest. Why was it here? How did it get here? This is what it looks like in the growing season. Um, there's 9 goldenrod species right there, and none of them are considered adventive or weedy. These are all conservative species. Um, so not just how did Solidaga puberula end up there, where did it come from? And how on earth was it able to assemble with density? Um, that's the tall spire in the center, right there. But also with it there, Solidago erecta in the lower right, Solidago bicolor, lower center, Solidago juntia with the red stem in the front. Bless you. Solidago rugosa aspera, Solidago rugosa rugosa. I see Altissima gigantea in the background. Anyway, there's 10 species of goldenrod right there. It's just ridiculous. And then when you walk in there, the same thing happens with Eupatorium. You get 8 species of Eupatorium in a very small area. 3 pycnanthemums. One of them's a hybrid between the 2 of the other ones. Just a really remarkable situation. So all of the questions that were in the program description that you might have read began to pop up. And what I want to do is to begin to think about some of those with you. So in particular, I'm going to pull up a couple of those, touch on a couple of those questions. So these are my notes. So, one of my big questions here that I want y'all to think about is many of these are strict heliophiles. These are prairie endemic plants, and they're non-weedy, so they're slow to assemble. Some of the species are gravity distributed. How the heck did they get there? Where did they come from? How did they move across the land? Why is there a colony in one location and then 500 yards there's another colony of that same species that is gravity distributed or ant distributed seeds? How do these things move around? Birds and wind, but a lot of these are not bird distributed. And a lot of them aren't mammal distributed or wind distributed either. Some of them have low germination rates. It's not enough to just be moved around. You have to have fine purchase in the right chemistry and biology before you can even germinate and reach reproduction. Never mind make 1,000 of yourself. So the theory that's being tossed around globally, one researcher in Asia is saying these sites have a mean age, an assembly age of 1,400 years for these groupings of plants. So this is a guy in Asia, peer-reviewed pub 2022. That's an interesting idea. And so it's not just that you have 1 or 2 of these things, right? 1 or 2 conservative species. You have 90 in 100 square meters. Like an absolutely biologically ridiculous situation. So think about that for me, if you will. They have to have a distribution path of some kind. They're heliophiles. So if they're going to germinate along the way, they have to have sun to get from one place to the other. We're talking about deep time and some sort of interesting ecosystem situation that's definitely not forest. And then so there comes the old adage, a squirrel could leap from limb to limb from the Atlantic to the Mississippi. Have you all heard that one before? That's what I learned when I was in school. So that takes us to this thing that folks are starting to call the virgin forest myth. And that is that, that when early settlers arrived, there was a virgin forest stretching from the Atlantic to the Mississippi. Ancient big trees, closed canopy forest, super rich. And there's just a lot of problems with that. And I think, you can go to some of the early explorers and just look at their journals and you see there's a problem with that. But I like this one. Stephen Pine was just writing about this phenomenon, and he's right. He's saying that it wasn't the forest that stretched the imagination; it was the grasslands. They didn't have a vocabulary for it, and it was this, what the heck are these things? And so you see these big expanses of grasslands noted on local maps in the 18th and 19th century. And we can have a look at some of those in a minute. But let's visit a couple of these. If I can get this out of the way completely. There we go. A couple of these quotes. Maybe some of you have seen these before. There's some of these guys are probably drunk when they're writing this stuff. But there's also a grain of truth, in some of these. So anyway, this one is a really special one. 17 describing Virginia Piedmont specifically in 1705. And it's describing this this mixture, valleys and plains, rich low grounds that are, well timbered, but in other spots there's, large meadows and savannas, where in hundreds of acres without any tree at all, but yield reeds and grass of incredible height. And this is repeated, I don't know, at least 100 times over. We did a research project looking at journals and trying to pluck things out. And I'm just giving you a few examples. This is another popular one that's shared, describing the Piedmont. And I won't read all of that, but you can see down at the very bottom, pasture for deer, elk, and buffalo, narrow meadows, swamp tracts, forests, and grasslands, a mixture, a description of forests and open spaces, right? Plucking from different areas, Virginia 1716, which lie along by the riverside, much like unto our low meadowlands in England, neither tree nor shrub that grows upon these plains. Fontaine. The land was without timber, covered with a rich, luxuriant grass with some scattered trees, hazel bushes, wild plums, crab apples. That's in Pennsylvania. North Carolina, that's a really interesting observation by Lawson. That's referred to quite a bit. That area of also noted as Grand Savanna in North Carolina. And there are lots of reasons, lots of hypotheses coming from other genres. This is, Reed Noss looking at fire ecology in the pre-colonial landscape. And this is the estimated fire return interval for the region of our interest, or most of it, the Piedmont region. And, you see that orange that's 1 to 3 years. That's restricted very much so to local relief, mostly less than 100 feet. So the right side of this line, of this orange area through Virginia right here, is pretty close to the fall line. We're sitting about right there in DC. So we're right on the edge of it. But so basically, there's the Potomac right there. So you can kind of head west just a little bit and you're going to hit that area. That's a natural fire return interval on flat landscapes every 1 to 3 years. And they're estimating this is without human input. That's remarkable. That extends right through the central part of the Piedmont, and in fact, through the area where we find the most density in the phenomenon of finding these little scattered remnants. So fire frequencies in the pre-colonial landscape. Anybody guess why there might have been more fires moving around the landscape without human input in the pre-colonial landscape? Any ideas about how that could happen? We've still got thunderstorms, but we don't have tons of fires everywhere.
Is it just that there was more brush hanging around because no one was clearing it?
You're on the right track, I think. There's more highly flammable material, but a lot of the explorers are saying they could see the horizon beneath the trees, so there's not a lot of brush, not a lot of, and a fire return interval of every 1 to 3 years won't allow brush buildup. Now, you think 10,000 acres of 50% cover of little bluestone. That's pretty flammable during a drought.
Any of the grass. Last year's grass is drying out there.
Exactly. In this year's green. Yeah. Yeah. So more flammable landscape, lower relative humidities because there's more sun on the ground. Less forest. The estimates are coming out of the Southeastern Grasslands Institute are 50-50. 50% forest patches and open grasslands. from Alabama to the Hudson River. So it's just more flammable. And then you get humans involved, and there are definitely, being an archaeologist, there are accounts of Siouan tribes burning 2 times a year in some areas. So some of these fires are moving around on their own. They're getting started. They're moving, going where they can on these flat plains. They're getting windswept in April, May. Um, they may catch a tree on fire, might burn into the ground, might pour down rain, but you might have a smoldering root mass that just sits there and waits for the drought that comes in 2 months. And then you've got a fire again. Um, that's a common occurrence now. You get kind of reignition and smoldering roots. That happened in Madison County, Virginia, a couple of years ago. They had a huge, like a 10,000 acre fire because of that, a lightning strike that happened 2 months prior. So let's think about that. This is an image, it's a collage that I put together just to stretch your imagination a bit. This is at our center. And okay, so that's the reaction that has to change. How do we do that? So what if this was normal and the last 300 years was not? And I laughed at this too. And everyone does. Everyone says that's funny. And it's because that buffalo's getting ready to move you out of the way. But it's also, a pretty ridiculous notion if you've grown up situated in that genre of everything was forested. So anyway, this is at the center. We're on ultramafic hardpan, a flat upland area. Had a fire return interval about every 5 to 8 years in the pre-colonial landscape. We know there are ultramafic woodlands there. And that's pretty much what they would have looked like. And we still have those trees there. The trees, some of the trees, their stems go back to 1590s, 1610s. These are blackjack oaks, post oaks, hybrids between white and post. And we use prescribed fire. We don't have the bison, and the visitors are grateful. But one day, I know somebody that knows how to do that. Anyway, want to stretch the imagination a bit. I think to the left here, you can see that thicket woodland behind the people walking in on the trail. There's the Piedmont today. I just removed that from the forest to the right and replaced it with the heliophiles that would have been in that landscape, the roses, the plums, the hazelnuts, the New Jersey tea, the blazing stars, the marble seeds, the lithospermums, purple milkweed, clasping milkweed, green milkweed, red ring milkweed. And there's fire back there in the distance because everything in here is adapted to that, emerged from it. All right, yeah, so that's when I had this realization. Okay, so I don't have the skills and understanding, ability, or language to describe what I'm seeing. That's the situation back in 2014. So time to do some science. That's what I knew how to do. Quantitative assessment as an archaeologist. I know about how to do dendrograms and cluster analyses and all that good stuff. And turns out same formulas work for quantifying plant communities or defining how different they are from one another. All right, so I want to give you a little bit here. The Piedmont region, just so you're clear, what I'm describing in this presentation is that white area. Extends from New York City, just to the north along the Hudson, down to Montgomery, Alabama. That is the Piedmont ecoregion. It is a unique ecoregion physiographically. It tends to be rolling, dissected uplands, low local relief, really flat plains in the eastern half, outlying monadnocks in the western half. And it's for the most part, it's basement rock to older mountains. So gneisses, granites, and some intrusive rocks, some ultramafics. And there are some Triassic basins scattered about. That's the region I'm talking about. Everybody know what a grassland is. This is something I spend more time on with other groups. It's an ecosystem that has lots of grasses. That's on the face of it, but also beak sedges, rushes, the other graminoids, sedges, carex, especially in the northern part of our study area. There's more sedges. Um, but a significant number of graminoids. So you can actually have a canopy, and if you have an herb layer that is, like 50% graminoids in both richness, frequency, and cover, you can call it a grassland. And I think that's going to be the biggest clarification for you guys, the types. We have this completely open canopy, the barrens, Xanthoparmelia, it- you know, where you don't have trees out in the middle. There's just nothing. It's bare rock. Um, and some of these they classify as grasslands, but barrens is the word that's used because some of them don't have any herbaceous species at all. Out in that Grimmia moss, there's nothing. Then we have prairies. We don't think there are any large significant prairies in the Piedmont region as a major trend over the last 8,000 years in the Piedmont. There's too much rainfall and there are too many tree species that are adapted to fire. They would just be there. So you have to have some unusual situation. This is one of those situations. This is an enormous, rare type of savanna where all the trees have been removed by people, modern humans. So there should be trees in there. That's American plum and post oak on the edge over there. They should be out there. So prairies are wide open, no trees. Savanna is widely spaced trees. That's what this is. Classic savanna, Piedmont savanna, acidic oak hickory type. And then there's woodlands. These are like 30 to 80% canopy. They're still not forests. See all the light on the ground? See all those grasses and sedges? This is a grassland. And honestly, there's a lot of species richness in the prairies and the savannas, but it's the woodlands where you have the highest species richness per square meter in the Piedmont region, because you have the heliophiles and the skyophytes, the shade lovers and the sun lovers growing right next to each other. Then you have these weirdos. There are lots of reasons to have grasslands. Disturbance regimes, bison, elk, floods, fires, things like that, humans. But sometimes the soil is just too wonky for there to be any tree growth at all. And that is called edaphic stress, when there's a soil or geologic stress that regulates the community. This is an example of an edaphic community where trees can't grow. We call this a frost prairie because there's significant 6 to 12 inches of frost heave 2 or 3 times a winter at this particular spot. So the trees just can't get a start. And interestingly, there are no non-native species here. If you look out, if you really pan out, this is what you see. Any ideas about what's going on there? I had a guest from the upper Midwest on a tour of this site, and the very first thing she said was, "Oh, those are old bison wallows." I was like, "What?" Because this is in Albemarle County, Virginia, and we've been looking for bison wallows, and I've been around these for years, and that had not hit me. But sure enough, there's a chance that's what those are. They're still used that way by fauna. These are magnesium salt licks. All right, let's get into the research. So, we have this big question. What are these things? And it's sort of, you know what? I'm going to show you guys a couple of maps because I really want this to hit home for you. Have y'all seen the old maps of the French and the Spanish? I just wanted to show you this one just for fun. This is North Carolina to your left, Virginia to your right. This is showing John Lederer's treks across the state. So you can see a big problem in the ecosystem assumption there. There's savannae, which is plural for savanna. And right here, you can see my cursor. There's what is now known as Rosawek, which is the capital of the Monacan at the confluence of the Rivanna and the James Rivers. So we know this is the Ravanna going to the right, the James going to the left. The Ravanna ends right in the middle of this Savanna, which is western Albemarle County. The Rockfish Valley, which is windswept and marshy, which is really interesting today. There's very few remnants there today. I think all of that was cultivated. But down here in North Carolina, we've got this path right here, Deserta Arenosa. And we know that explorers that went through that area, some of them didn't see any trees for 30 or 40 miles at a time through that area. And it's interesting that that was called the dry desert in the 1670s.
Ask us the date.
1670s, yeah. Yeah. And this pattern keeps going. I'll show a few of these to you. This is another one from the late 1600s. And you can see right there in the same location, Savanna. And this could have been copied from the other map as an assumption, but it is still notable. This is a later adaptation. I've got Savanna written right here in the middle. The Rickahokans, that's the Appalachians now. We have this really interesting patterning right here, the stippling. And we have all of these Siouan names, Akanatsi, Menaken. So this is all Central Virginia right here. That's the James drainage. And we are finding the most phenomenal grassland remnants down in this area where this stippling is. Some species that are endemic to just that region only occur at 2 or 3 sites on the planet. Marshallia legrandii, for example, the oak barrens, Barbara's buttons. So they have their evolutionary roots there in this location. So anyway, there's some other really interesting bits there. So if we can keep going through the national ones, but what I'm finding is that if you go to local courthouses and start digging through maps of the late 1800s, you're going to find different place names than are there now. And this is one of my favorites from Madison County. It was an area known as the desert. There are also, you can see the word meadow right there. There are lots, Burnt Woods was the name of this area. Uh, so, oh, look at that. There's another Burnt Woods over there. So if you go to the desert today, you're going to find incredible flat rock plant communities, Andropogon gerardii, Panicum virgatum, Sargassum nutans, things like that. Big colonies of that stuff with high species richness in the forbs in association with them. Opuntia mesacantha, the southeastern prickly pear, Humifusa in some areas. But really beautiful remnants there. Open canopy still. So, locally, here's Savanna County, 1820. I'm sorry, the one I just showed you was 1890. This one. And by 1910, all those place names are gone from the maps. And I'm wondering if that was a concerted effort nationally on a local scale when the fire laws went into effect around 1910. It became illegal to start fires, and it became a national trend to put them out everywhere. Canopies closed. But this is Fluvanna County, and down here in the corner, the local historian has written the word barrens, but you can see it in the backdrop there. And in fact, the entire thing is pine barrens. And that's synonymous with areas with sparse vegetation in the 18th and 19th centuries, the word barrens. That's a common thing near here. Western Maryland, the barrens. Soldier's Delight, the barrens. So anyway, we're seeing stuff on the local scale. Really, really interesting things. And we did have an intern that decided to go ahead and georeference place names across the Piedmont region of Central Virginia to begin to pluck out to see if there were grassland related place names. And I mean, anyway, they're everywhere in the historic record, land patent records. Barrens, the Plains, Buffalo Creek, Buffalo sightings mentioned, Buffalo sightings, Buffalo Springs, Elk Hill. Down in there's areas that are called red levels that have a high density of remnants that we're finding. You've heard of Big Meadows. There's also Little Meadows, Green Meadows, a place called Grassland, Virginia. Anyway, this list is pretty long, and she did a great job and was able to reference the maps. So we're hoping to make this into some type of interactive web map that we can share with folks. So we can get a picture of how these place names changed through the 17 and 1800s and into the 1900s. Be really cool. Okay. So I think the birth of the project is pretty obvious. There became this need. The goal is to find as many putative old growth remnant grasslands as possible. Nobody understands really what they are. Some plant community ecologists, Chris Ludwig is a good example, had a hunch. Folks at DCR, Natural Heritage, they've been studying and plying into these grassland communities for decades. Folks down at Austin Peay State University, Southeastern Grasslands Institute, people out of the Carolinas were aware of these grasslands communities, but could not really position them within the larger landscape of plant community classification. So we wanted to find them, find as many as possible, document them, and describe them. That was the goal of the project, started in 2018. We know that there are patterns about where they continue to persist. We wanted to figure out if that was true, if the data would play that out. We know that there are different types. It's not just all one interesting, diverse grassland. There's types. Some of them are rare, so maybe they should be afforded protections. And then ultimately, how can we begin to save them, right? So let's get into this. I want you guys to see the methodology here. The very first step, believe it or not, is you have to get in your car and you have to drive. So the research team we assembled is really resilient and competitive. And I can show you those folks before I show you the method, so that you can see who these folks are. It's a really resilient team. These are the co-leaders of the research team that hits the field. They get in the car and they'll drive. It'll be a 12 to 14-hour workday. They'll drive every back road in a specific study area in a county. All of them. They'll get out of the car. They use respectful trespassing as a rule of thumb, and we define that. If there's purple stripes on the trees, which means shoot on sight, you don't cross that, you don't go past that tree. You communicate with people that you encounter, but they've gotten really good at this process. That's Emily Lubke and Drew Cheney, and they lead the field team. We've also got co-PIs. That's me on the left. That's Dr. Mary Jane Epps. She is now with Virginia's Natural Heritage Division, manages the preserves. And Leighton Reed on the far right is my other co-PI. He's at Virginia Tech. But Jesse Wingo and Evie Sackett have been important contributors. And all of these pictures are people standing in putative old growth remnant grasslands. Ezra Stengel down there in the lower right, he's going to be the author of our next publication, peer review. We'll make sure that you guys get that. It's going to describe the putative pre-colonial grassland types of Central Virginia. There will be 8 described in that peer-reviewed paper. We're waiting to hear back right now. David Belonge started off as an intern and is now the manager of our local ecotype nursery. But he also joins the team on survey. And I included this picture. Oh, there's Jordan Cassia, Dr. Jordan Cassia on the far left. She's a data analyst who is also working on publishing some of our data. She's now with the Southeastern Grasslands Institute. And the picture on the right is the most diverse grassland remnant discovered in the state of Virginia. There are 128 species and 100 square meters. And that's second only to a spot in the southeastern coastal plain, a longleaf pine savanna, which tops it, but not by much. And this is in Goochland County, Virginia, and the power line right of way that used to be a telegraph, a telegraph line, which preserved something of a broader ecosystem in one little patch on the edge. And then every year we get new staff, we get interns that join, but that's usually the crew size right there. It's about 12 to 15 people a year. So we're headed into a research season now. We have interns as well, and we've already hired those for this season. All right. I wanted to show you, get back to this guy right here. Okay, so we drive, those folks drive around. The first step is to find all these sites. And this takes a lot of practice. A lot of you are really good botanists, but to be able to see a remnant as opposed to an interesting occurrence of a plant, two different worlds of thinking. You have to be able to see the patterns, and it just takes a lot of practice. Botanists learn it in one season. And got it down. I think everybody in this room could probably do this very quickly. Learn how to see these or distinguish them, even at 55 miles an hour. Once we locate all of those sites, we then go back and put quantitative assessment plots, 100 square meter plots, in the ones that are the highest quality and also the most representative of each type. And the amount of data that we collect in here, you can Google it. It's standard natural heritage releve data for community sampling for grassland communities. All of that's listed in here. We do take soil samples because they give us an independent look, an unbiased, completely unbiased look at community types. And then, once we have all of that data in, we can start, crunching the numbers. And while we are doing this project, this is the app that we use while we're in the field. It has a tracker on it. Our WebGIS guy keeps this up to date. So what I want you to see is how many sites we found. So there's the Piedmont region in white. The black lines are the counties we have covered so far in Virginia. These are the remnant sites so far found across that region. Looks like a lot, right? And it's less than 5% of the square mileage of the region. The orange dots are high quality grassland sites that are probably pre-colonial remnants, at least the herb layer. The trees are gone. Some areas are really concentrated, like down here, extraordinary preservation because of the geology. It was just never plowed. The red dots are where we have quantitative assessments. And guess where we're coming this year? So we're going to be doing the entirety of Washington, D.C. I hope we find one. Anybody know where a remnant is within the city limits? Exactly. A lot of fill, right? And we are going to be leaning on the Potomac Gorge for those riverside terraces and prairies. And the Maryland side of things, the northeast side of Washington, D.C., there's going to be at least one up there. So we're going to do Washington, D.C., Loudoun County to wrap up Virginia in the north. And then we're going to go ahead and head down here to the southeastern counties and do those. So those are the focus of this season's research. Just to give you a feel of where we drive, those are the driving routes. This is our proof. Frequency, linear miles driven, linear miles that have remnants. You can algorithm this and stretch it across the land between them and make estimations. We think we're probably seeing less than 10% of the remnants that are out there because of our limited view. So that's exciting. You just have to have a region that has, soils that were never plowed. That's the key. 300 years of plowing is what really screws things up. The plow is the equivalent of cutting down the old growth trees in the virgin forest. It's the same thing for grassland. That's what's happening. Just you're undoing it. You're permanently unzipping something. It's gone once it's gone. And so some of these areas are just packed, with grassland remnants. Other ones, look at this. Western Albemarle County, right here. Madison, Greene. Just some areas are just so cultivated, there's nothing. even though we've got descriptions from early explorers describing cool things there. Oh well.
Well, how big of an area do you consider a remnant? Does the definition of your remnant, how big does it?
Can you repeat the question so that?
Yeah. The question is, how big of an area do we consider to be a remnant? And this house has to do with integrity and resilience, not size, for our research purposes. So if the plant community is completely intact, it can be the size of this room, and it's a leftover. And the cool thing is, it turns out this is the part that's really been overlooked historically by ecologists. Remnants of that size have been written off as loss because they can't sustain. And what we're finding is hundreds of, couple thousand of them that are that size. And so no, they're still here. And in fact, you can see the plow line in the plants. You can see stilt grass over there, and it just stops. It does not leap across that line into this area. It's a hard line. The seeds are definitely there, but they are resilient. So the smallest ones we have seen have been like the size of a living room that are remarkable. I mean like really high species richness, mean C value, coefficient of conservatism. Has anyone heard of that or not heard of that? Coefficient of conservatism. Okay. Um,
Yeah, I know about the coefficient of conservatism.
okay. So some of you do. Every plant is assigned a number that reflects its ability or inability to colonize on disturbed landscapes. So a liberal species, let's say, is ambrosia, common ragweed, or broom sedge. They're adventive. They can colonize in a crack in the sidewalk. Okay. Um, you can have something like
What number would they be in?
a one,
Yeah, okay.
yeah, a zero. You get up to one and two, you get common milkweed. Three, you get the butterfly milkweed. Four, five, I think I'm guessing right here. Green milkweed, clasping milkweed. You keep going up, you get red ring, whorled. In the higher spectrum, six and seven, you get purple. Torrey's mountain mint, eight. The the species that have a hard time germinating, reproducing, spreading, they don't tend to associate with landscapes that have been previously quarried, plowed, developed. Basically, the soil column, if it's been disturbed, they're
So
not colonizing.
they vary by state and by um, like ecoregion, and
They
so
change significantly. That's correct.
so for
Yeah,
instance
there's
something in the Delaware coastal plain is going to be the sea
right.
values are going to be different there than in the Virginia Piedmont or whatever.
You're absolutely correct. Virginia has its own C value list that was produced by Virginia botanists. That you're right. North Carolina is very similar to Virginia, but it changes significantly when you change ecoregions. Yeah. Yeah. So, these remnants that we're finding are intense concentrations of high C value species. The mean C is, 5 or 6. Pretty cool. Okay. So we use this app on the fly. This gets updated as we're moving. Um, and what we're doing when we're flying down these roads is we're not breaking laws and having accidents, which that's not really wood, but knock on wood, you know, so far so good. Um, and the team has gotten really good at discerning between these. There's a gradient. There's extremely intact, highly undisturbed ground surfaces. And then there's highly plowed areas, and there's actually a gradient between the two. You can have a beautiful remnant site that's had spot disturbance, and you can see that in the flora. The mean C is going to be lower, the floristic quality index is going to be lower, things like that. So I hope that's an introduction to coefficient of conservatism. The range is 1 to 10. In Virginia, it's -5 to 10 to account for exotic invasive species.
Five.
There's -5.
Oh.
Oh, you tell me. Arthraxon hispidus. I'm guessing that it's I don't know, but I'm thinking it is. Microstegium feminium, probably. Um, Sorghum halepensis, maybe. Yeah. Okay. So yeah, we love this app, and the crew has gotten used to seeing these things flying down the road and documenting them. They take about 10 minutes to document first time around. Indicator species, high fidelity heliophiles, high mean sea, move on. And some days, poor teams will drive like when they're out in Goochland County, Eastern Goochland. Oh my goodness, you know, just drive and drive and drive and drive and yawn and drive. Um, in some of these areas, there's just nothing completely cultivated. Anyway, I wanted you guys to see this. This is an inside look at our operation. This is not an app that we share with people. But you guys aren't getting the standard PowerPoint today. You're getting a look at the inner belly of the beast. And some of this is probably confusing for that reason, or because of that.
No, but when you zoom down,
Yeah.
you see all those dots. They're not actually the areas that you've covered because you've left the dots large.
We've got polygons. Oh, yeah, you're right. You're right. No, when you zoom out, it shows
You find are much smaller than the dot you have represented them.
the dot doesn't scale down.
Yeah.
Yeah, it stays big when it's like,
It's like, oh, you covered the whole thing. Look at those dots there. But
well,
it's small sections that,
for our research question,
yeah.
we've covered those areas, and it's a good way to see that. But it's so important to zoom in and realize this is less than 5%. Average of a remnant every 10 miles of driving. 50 remnants per county is the average. Give you a feel. All right, so the unexpected quantity is something that we discovered. I'm going to just hit some discoveries here. We have so far found 2,196 remnants in 46 counties and cities in Virginia. 360 of those we consider high priority conservation sites. We think in 50 years, if these can be saved from development, data centers, things like that, they will be high priority natural heritage sites. Some of them have extremely rare state rare, globally rare species in association with them. And the community types are rare too. Where once they were widespread, they're now like really relegated to these edges and these little in-betweens, I think the most common place to find one is between the plow and the edge of the Colonial Road. It's like a 10 to 50-foot wide strip. If you can find that little thing, that bugger, if it happens to have an electric distribution line that has replaced a telegraph line and it's unplowed, you've got a good spot, unless it's been sprayed.
How about railways?
Railways used to be, yes, especially in the Midwest. That's a phenomenon because there's lots of spark fires in association with those corridors. But the landscapes really squeeze the remnants out, plow right up to the maintenance line of the railway. But the landscapes right next to them definitely used to be, and that probably still is the case. And we see interesting species, but no intact communities along those at this point. All right, so I know you guys want to see some flora, and I'm just gonna take you down to Halifax County. This is a metabasalt hardpan. The Department of Conservation and Recreation, Johnny Townsend, Chris Ludwig, Gary Fleming, Karen Patterson, and others have been studying sites like this for decades, and this is one of their favorite study sites. This is where we have some crazy endemism going on. There's smooth coneflower there. I'll show you a couple of these plants. Echinacea labigata. This is an extremely rare plant that has a broad range in its occurrences. I think there's is there not a spot in Pennsylvania or in Maryland that has smooth coneflower, and then disjunct south side Virginia and then North Carolina and south from there. But there, that suggests that it may have been more widespread in the pre-colonial landscape. Carolina rose, Rosa Carolina. There's New Jersey tea. green and gold. This looks like Cirsium carolinianum, Carolina thistle. It's a pretty rare plant in Virginia. It's a conservative thistle. Who'd have thought? There's a mixture of the bunch there, the smooth coneflower and the Carolina thistle. Beautiful. That's Danthonia sericea that's all mixed in there, the silky oak grass, that really tall stuff. There's probably some black needle grass in there too. Ooh, Clematis ochrolouca, curly heads. Oh, here we go. This is Marshallia lagrandia. Just a couple spots on the planet for this. 3 now. 3 known. Oak barrens, there's a little patch there. There's our survey crew. We were able to get a quantitative assessment in and around this population to see what its community association is, which is really important to find the context, seeing what community type it is part of statewide. Yep, dirt. Soil samples. Okay, so it's a gorgeous flower, Echinacea laevigata. Let's see if there's something else in here that we can look at real quick. Guylinia. Oh, that's a beautiful photograph.
I'm from Maryland, and you mentioned the echinacea in Maryland. I didn't think there was a single echinacea species in Maryland. I may, not have heard of something, but I don't believe there's any echinacea.
I don't think there is either. I think it might be Pennsylvania, and it might be historic.
Okay.
Yeah, I'm looking at FloraQuest right now. I can answer your question. Yeah, I think that is the case. So, yeah, you are correct. Affirmed. It looks like Virginia to Alabama, historic. Yep. So I take it back on the Pennsylvania. So, this picture just, highlights how the fauna is there as well. When we find these remnants, we're also seeing rare animals. We're making some new discoveries, some state record discoveries in the animals, and that is another presentation. And a lot more research needs to be done there. But this site is at Difficult Creek Preserve in Southside Virginia in Halifax County, Virginia. And it's a truly remarkable savanna remnant. The DCR has done a really good job of taking a loblolly pine thicket, and thinning it, getting rid of the loblolly, and just reintroducing fire, and allowing not the seed bank to wake up, but the root bank, the bulbs, the corms, the tubers, the roots to wake back up. And they've been dormant for a long time. They've been in the power line right of ways and along the old roads, the colonial paths. But they've done a great job of allowing that to wake back up. Okay. Let's see. We've got thousands of photographs. We curate a rare species list. I'd be happy to get that to you guys if you'd like to see what that list looks like. Every year we send our entire data set to the Department of Conservation, Recreation, Natural Heritage, Southeastern Grasslands Institute, but comprehensive stats, just everything. All the community data, all the rare plant occurrences. We make sure to share that. So let's get down to this. I want you guys to begin to think about how to see the difference between the two, and this is the easiest way to do it. Let's go 2 different places I could go here. This will be the quickest. Oh, for the data geeks in here, we're going to do this first. All right. When we try to understand how these grasslands are different or similar, we use a dendrogram iteration, and this is one that reflects just 2015 to 2023. There are 2 years of data missing here. So there are more types. But what's going on here is, so these tiny little letters down here, these acronyms, each one of those is a vegetative sample plot, a 100 square meter grassland sample plot, okay? And this is a family tree, essentially, showing the relationships between the grasslands that we study each of these plots. And this is strictly showing vegetation. This is not showing soils or physiography. This is saying how different or similar are these plant groupings from one another. And if they are different enough from one another, they constitute being recognized as a natural plant community. And there are thresholds for determining that. This dotted line down here, the black dotted line, is the threshold set for this particular data set. So anything, any split that happens above it is considered valid. Things that happen down below it, we need more data before we can split those into community types. So here we have 8 types. Yep.
Is this from Jordan's paper?
Jordan might have used our data for that. Yes. Yeah, Jordan Cassia's paper leans heavily on the data from our research. And I think she might have used this graphic. So here's the first split. We get on the left, we get plant communities that are on these unconsolidated sands, Pliocene, Miocene sands way out near the fall line. Saturated silts, sands, and clays, alluvium, water deposited things. On the far right, we get bedrock that is weathered in situ. So you either have bedrock or you have clays that are weathered from bedrock. Okay, so you have silts, you have alluvium, silts and sands on the left, and heavy water influence on a daily basis. And on the right, you've got deeply weathered clays and bedrock. Okay. So the next split down here, over in the sandy, we've got the sandy savannas, which are very restricted to the outer part of the Piedmont, close to the fall line. They're very closely related vegetatively to the coastal plain woodlands and savannas. And then we have wet savannas, which are seepage grasslands, and they can creep in from the outer Piedmont into the Piedmont uplands. And over here on the right, we've got these deeply weathered savanna types that are divided into 2 types. There's acidic and there's basic. And the basic over here also includes, tends to include bedrock dominated communities, but that's the way this split out. So the acidic savannas over here on the left side, 3 types panned out in the data. And these are all types that are recognizable driving by. They're indicator species for each of these types. So the southern acidic oak hickory savannas tend to be restricted to south of the James River. Northern acidic oak hickory savannas tend to be north of the James. Pine oak heath savannas tend to have tons of ericads, and they bridge that line. Now out here in the basic group, we get basic oak hickory savannas. So this is circumneutral pH. Base saturation is high in the soil. Mafic and ultramafic bedrocks and hardpan. And then we get barrens, the flat rock barrens, with all the lichen incrustations and the dry rock mosses and things like that. And then this is just an analysis that shows relationships between these groups. And I'm sorry I don't have this more legible for this presentation. Relationships between the groups and physiographic factors. So this is a multi-dimensional graph. The longer those blue lines, the greater the influence of the physiography is on creating the community type or influencing the community type. So we have this one, way off to the left, we've got iron, surface cover of water, relative moisture index extend off to the left here. And sure enough, you've got those communities that are sand and water oriented, clustered out on that side. So this pattern continues. Of course, you would expect higher elevations right here, that long line. So we've got Western Piedmont mafic barrens are way out here. So elevation plays a big role. Relative slope plays a big role in defining these communities. So we're beginning to understand, what it is that these vegetative communities associate with landscape-wise. We can begin to describe them in a traditional natural heritage manner. What geology, what slope, what aspect, what latitude, longitude, what is the chemistry. And it's nice when things begin to cluster like this strongly, because they're, being able to describe those communities with legitimacy and saying they are unique communities is great, but you can see right here in the middle, this is a mess. And so we probably need a bit more data. These are the acidic oak hickory savanna types and the basic oak hickory savanna types. So there's a lot of overlap in those data, which suggests maybe we should be lumping those community types into a single instead of splitting them. All right. So here's the part where you guys, I'm gonna leave you with this, I think. We're at a little after 8. So how do you tell the difference between these? And I think all of you in this room can do this. We have everybody that comes on staff has to learn how to do this. It's doable. So there are 2 types, ruderal and remnant, okay? The ruderal is definitely vegetation that is growing on previously plowed, cultivated, pastured, mined, disturbed soil, heavily disturbed land. This is not surficial. This is not prescribed burn. This is a situation where the soil has been turned over, has been heavily disturbed or translocated, redeposited subsoil. So ruderal grasslands occur on those landscapes, okay? Remnant vegetation persists on unplowed soils, natural and stable ground surfaces, and they are hypothesized to have a strong pre-colonial element to them, the herb layer. The trees obviously were cut. We rarely find pre-colonial trees associated with savannas. They are around, and sometimes they're hiding right in plain sight because they're not that big. So, typical quality here. Usually, if you slow down and you start looking at the plants and you start counting species, you're going to have 25 or fewer native species. Let's say in an area twice the size of this room, just 25 or so species. And that's normal for all these old fields that you drive by. These weedy power line rights of ways, most of them. Roadsides, most of them. 25 native species. You're going to have a ton of non-native early successional weedy species also. And there's some evidence to suggest that these big fields packed with tall fescue, Kentucky bluegrass, compressa also, these other weedy, adventive, non-native and native grasses, once they're there, they don't change much if it's kept in a grassland state. Here's some indicator species that you're all familiar with. Common milkweed, horse nettle, broom sedge, frost aster, tall goldenrod specifically, annual fleabane, crown beard or wing stem, those 2 species, and super weedy early successional things like American burnweed, pokeweed, horseweed, things like that. These are all really typical and usually prevalent. Okay, native species. And these all have tremendous ecological value in disturbed landscapes. So a remnant, on the other hand, in that same space will have 70 to 120 native species. They'll have rare and uncommon species. And sometimes the rare plants are the most common plants in that location. So it's really flipped on its head, the whole logic. Most of the plants aren't tolerant of soil disturbance. Some ecologists think that a lot of these high conservative value plants will never recolonize those landscapes again because the key ingredient is time. On the order of thousands of years, not decades. Usually there are very few non-native species. So standing before Dr. Mary Jane Epps here is a remnant, a truly remarkable one. And flying down the road, that sort of pattern right there, that Eupatorium, Liatris, Erianthus pattern is like, hit the brakes. There's a lot of species in that spot. And they are hypothesized to be leftovers. Here are some, and this really varies, when you're dealing with this many species, the diversity that's there, it's hard to pluck some out, but these are strong indicators in Central Virginia. Green milkweed, narrowleaf mountain mint, moving across there. You get the blazing stars, particularly scaly blazing star and grass leaf blazing star. Uh, Symphytrichum dumosum, the bushy aster, thoroughworts, the conservative thoroughworts, um, goldenrods, the conservative ones. There are some that are non-weedy goldenrods. I know that doesn't sound right, but some goldenrods are extremely conservative. And big blue stem occurring naturally, local and regional ecotypes is extremely rare. We got these really reliant semi-parasitic plants like purple false foxglove. And sunflowers show up. Yeah, little blue stem is the strongest indicator for a remnant. You can see it at a half a mile away. There'll be a patch up on the hillside. That's the remnant. And it's pretty conservative grass. It does really well when it's seeded after year 3 in restorations, especially with a Midwest ecotype. But we use that species to see things at great distance. And usually when we dive into a spot with about 50% cover of that, there's 70 to 100 other native species with it. It's fantastic. I could keep going with this list, but you get the picture. So, there are some other subjects we can cover. I think the where do they persist and why is another one that's really interesting. They definitely occur more commonly in areas that were not arable, meaning plowable, or it wasn't economic to try to produce hemp, wheat, corn, flax. Orchards don't work in some hard pan landscapes where the base saturation is really high. And we do find them in utility rights of ways as long as the soils are unplowed. Huge areas of central Virginia known as jacklands that have shallow hard pan and rocky soils. That's one place to find them. There are these beautiful places called insurance prairies where families were keeping big patches of these old grasslands as backup for their failed hay during droughts. These systems do well during droughts, and they still need to feed their cattle and their horses. So they keep these backfields of the old prairie just in case they got hit with a drought and couldn't produce their usual fodder. And yeah, of course, you can't plow flat rocks. So we do find remnants in association with big flat rocks. This is in Madison County. And this is my favorite. This is when, family tradition, multiple generations. They just love how beautiful it is. So they keep it open with fire or mowing. And if it's unplowed, this is typically where we find the most phenomenal situations, where we find rare plants growing by the thousands. And this is down in Fluvanna County. It's about a 20-acre remnant. Colonial paths in coincidence with local electric distribution. That's the hot spot. So when y'all are driving around all the back roads that are not in this area, but if you get out in the western part, get out into the county, there are lots of remnants in the counties to the west. And a lot of them occur in association with colonial paths.
And we might want to wrap up soon and save a couple minutes for questions.
Sounds good. Okay, so this is the last slide then, and I think this is really important because do you see that view out through there? That grassland is older than the woods next to it. And so a really cool thing can happen, and that is if you step into that forest and you thin it and burn it, it wakes up very quickly, especially if that forest is less than 100, 120 years. Preservation capsules out there. So yeah, with that, I'll go ahead and take some questions and we can wrap up. We are going to be, producing some a couple of publications that's going to help communicate some of this stuff, give you some education information for the general public. And we really need it for folks to begin to learn how to see these things and understand their value for biodiversity. They are among the most diverse systems on the entire continent, second only to longleaf pine savannas in the southeast. That's kind of cool.
First of all, thank you.
Absolutely. Yep. Thank you for having me.
So maybe we can toggle between online and here. I'm just curious, your organization, where do you get your funding? What's your livelihood in terms of
So-
doing this work?
Doing this research does require a significant amount of funding. And we get about 40% of it through grant applications annually. And then that is usually matched 1-for-1 with private donations. And then we contribute the rest as pro bono work because we just love doing this stuff. Yeah.
Thank you.
So we are in the middle of fundraising for this year right now. We did just get a grant, a $50,000 grant. So I'm obligated to find 50,000 to match by June. And yep, we're, in the past we've plowed forward without funding with our fingers crossed and then kind of backfilled that funding source in July. But yeah. Any other thoughts or questions?
Nan McCary has a question.
Yeah, I hesitate because I hope I didn't miss something here where you've already explained this, but of course, there's always this ongoing thing about fire, and I probably just need to read Moss's book. But I didn't quite understand if you were saying that fire was instrumental into these being maintained in prehistory, or are these not anthropogenic at all, and many of them would exist if humans had never arrived? I didn't quite understand that.
Okay. I think most of these grasslands have to be considered not anthropogenic, but human influenced.
Okay.
So their origin, humans aren't driving the evolution of these, 1,500 heliophiles in that manner, but they are managing systems and they are foraging and they are cultivating. So they were contributing and assisting the plant communities. I think that's the best way to think of it. There were definitely natural fires, some areas that had high fire frequencies, just from lightning strikes. But escaped fires, I think, is one that, having grown up in the South, having been a proud redneck of my own, little fires started here and there can really get away. And I think in a flammable landscape, in a pre-colonial landscape where you're managing last year's, field with fire, an escape is pretty easy. I think there are lots of things you can think about that might have happened, but I think a lot of these plant communities are influenced by human ignited fires. And the historic record bears that out. There are definitely descriptions of fires being set to some areas more than one time a year by humans. But there's edaphic stress. There are rocky landscapes. There are frost heave landscapes where the trees just don't completely close as a forest, even if you have no fire at all. We see that today. So it's a mixture. But I would say, humans have had a really strong relationship with these systems for a long time, for at least 9,000 years. Question over here. Yeah, do we get shot at or chased off? I haven't been shot at since I was in high school. Southwest Virginia,
Probably not due to plant collecting, right?
bottle collecting. No, yeah, so it's sort of that's a great question. We have only had positive interactions with all spectrum of people.
Are you asking for permission to go on the?
Absolutely not.
Wondering
We
that-
don't trespass. We don't go past trespassing signs. If it's a power line right of way along the edge of the road, and the property sign is on the back side of the right of way, even though that's their property, we'll jump in and have a look. No, no, I mean, we have had people pull up with, with firearms, with, and uh, immediate questions, what are y'all doing? And we explain, and they're like, holy crap, that's cool. Tell me more. Or let me show you this place that you can't see from the road. That's always a fun one. Yeah, we run into that. Or let me tell you this story about my grandpappy that used to call this whole area prairie. Or my uncle that called that area over there the glades, and they used to have to get through the glades to get to town. Stuff like that. You just never know what's going to turn up in conversations. But we've never had a negative encounter. Yeah, to date. Great question though. It's a valid question. Yeah, we could get in trouble, but we're careful. Other questions?
There's a question in the chat from Marion. It says, do you know of any organization doing this type of work in Maryland?
We will be next year. But the Southeastern Grasslands Institute is focused on the entire eastern grassland biome area, which stretches all the way up past Manhattan. The folks at Soldier's Delight are good curators of this type of work and information. That's all I can think of off the top of my head. I'm sure Natural Heritage in Maryland is also doing work in this genre, trying to understand these historic plant communities and the role they play in the bigger conversation around conservation, biodiversity conservation. It's an important topic in every state in the East. Most of our bird species that we've lost are grassland bird species, the ones that are in decline as well.
There's a couple more, and I just don't want to.
Yeah, what are the other questions in the chat?
Be here after.
I'm missing that because my bar is frozen down at the bottom.
Is there a minimum size to plant communities in Virginia, i.e., how mappable as plant communities? Are there places where soil surveys can be indicative?
Ooh, yes, there is a minimum size for plant community classification that's been communicated to me through the Natural Heritage Department at DCR. For forests, you need 400 square meters to quantify a forest block, but that if it's just 400 square meters, it's not a very sustainable system. So I'm not sure about the forest size, but I know with a grassland remnant, to call it a community, you need to be able to fit a 100 square meter plot within it, and it's good to have it be 4 times that size outside of that to be a sustainable plant community type. And you definitely use soil maps. Well, you can use geology maps or soil maps, and when you mix the two things, you get murky, we have found. Predicting grassland remnants using geology and soil maps does pan out in some regions. Buckingham County, there's the Jackland series soils. That's a hot spot for grassland remnants. And it's named after the blackjack oak, which is a grassland fire-adapted endemic tree species. There are grassland series, soil series. So stony soils, hard pan soils, those are layers I could have turned on in that app. We have those mapped across the state and we use them. We are careful when we go across hard pan stony landscapes because they tend to have more remnants because they couldn't be plowed. Or they don't perk, so they don't get big developments, the hard pan landscapes. Okay.
Do one last question.
You've been waiting patiently.
Yeah, I guess it was whoever did your GIS. I can like there. That's great.
Matt Smith is his name.
Smith, cool.
Yeah, he's a rock star.
Great. And just like wondering, like, are the remnants like visible enough to maybe like do some sort of like machine learning? I don't know anything about that, but like to then be able to use satellite imagery to like possibly assist your work.
We've tried doing that.
Yeah.
And in ground truthing it, it's messy. It really depends upon the phenology, the phenological expression times the type. Like there's so many components. So it's going to look this one color suddenly with an aerial image. Definitely a remnant.
Right.
Only in that type. So if you don't know the types already that you're looking
Right.
for, or
You have that whole database already. It's just like, can you now use it to identify the other 90%? Because you're saying 10% just by road accident.
I think we could probably define probability for them occurring based on frequency and geology. I think we could probably do a probability thing. Yeah, be my guess. That is ideal, but there's nothing that beats getting in the car and actually going to look. And you always find remnants where they're not supposed to be.
Cool.
There's no clue, nothing. Why is that there? Is that a new type? Is that a county record species? Yes, voucher off to the herbarium. Yeah, you get out there and it's mind blowing. At least half of the discoveries in a single day of reconnaissance fit that category. I'm just like, whoa, okay. That's new information. Yeah, it's exciting work. And heartbreaking because we get to watch these things get destroyed every season. Because nobody knows how to see them, and those that do don't care yet. They're not they don't have legitimacy yet from the standpoint of conservation easements because of their small size. That's one problem. There's lots of issues like that.
But I love that word yet.
Yeah.
I think that might be a great way to close,
Hope.
which is hopeful, right? And
Well, the more we learn, the more we share. Yeah. 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 So follow-up emails are welcome. I'll get you guys information when we've got the pubs. I'm going to spread the word. And I'd like to get all of you in the field so you can see these things. And I know you all chase them intuitively.
I'm in Maryland. Going.
Yeah, 2027. Thank you all for having me. Cool. Thanks for hanging in there.
I actually like right around the corner.
Was there a time limit on that?
Midnight.
Oh, really?
That was your thank you now.
On the other side of the system, often, like you said, back to